Hi everyone. Today we are going to discuss an important topic in soil mechanics is stability of slopes. This topic play a crucial role in the design of slope in highways, railways, embankment, earthen dams, etc. Okay. Understanding the slope stability help the engineer prevent the landslide and structural failure. In this lecture, we will first understand what slope stability means and why it is important. Then we will study the different types of slope failure, causes of slope failure, method of slope stability analysis. Finally, we will see how slope stability can improve in practical engineering works. The first thing is, what is slope stability? Here, a slope is an inclined surface of soil or rock exposed to the atmosphere. Slope stability refers to the ability of this inclined surface to remain stable under gravity and external forces. In civil engineering, slope stability analysis is necessary to ensure that slope do not fail and causes damage. Mainly, slope may be natural, such as a hillside or the river bank, or man-made, such as a embankment, cutting, earthen dam, highway slopes. Okay. Here, simple one example is landslide occurring in hilly region during heavy rainfall are typically example of the slope instability. And the importance of slope stability analysis is essential to protect a human life, infrastructure, and the environment. And then failure of slope can lead to road blockage, collapse of retaining structure, and loss of the property. And then proper analysis allows engineer to design safe slope and also reduce the long term maintenance and repair cost. One example is proper slope analysis in hill roads help prevent frequent landslide during the monsoon season. Okay. Then next one is the types of slope failure. In the rotational failure occur when the soil mass move along a curved slide or slip surface. The movement is downward and outward, and the slip surface is usually circular in homogeneous soil. In the non-homogeneous soil, the slip surface may be a non-circular. In the rotational failure is common in the cohesive soil such as clay. Here these are all the types of failures in the rotational. Okay, here three categories are there: toe failure, slope failure, base failure. In the toe failure, the slip surface passes through the toe of the slope. You see the image. And in the slope failure, the slip surface intersects the slope above the toe. Okay, in the base failure, the slip surface bases below the toe and generally occurring in the soft soil. Okay. In the transaction failure occur along the nearly plane surface parallel to the slope. It commonly occurs in the infinite slope where soil properties remain uniform at a certain depth. This type of failure is typically layered soil and shallow soil slip will happen. Next to failure is compound failure. Here compound failure is a combination of rotational and translation failure. This failure surface is curved near the top and bottom and nearly straight in the middle portion. You see that image. This type of failure usually occur when the hard stratum exists at a considerable depth below the toe of the slope. The fourth failure is a wedge failure. Wedge failure occurs along an inclined plane and is known as a plane or block failure. It occurs when the soil or rock mass break into the block or wedge that slide along a weak plane. This type of failure is a common rock in the slope. Then next one is a miscellaneous failure. Here, apart from the major type of failure, slope may be also fail in the form of soil flows, spreads. These failures usually occur in the saturated fine grained soil and are associated with the higher water content, low shear strength. Okay. will happen. After that, the causes of slope failure. Here, causes of slope failure when driving forces exceeded resisting forces happen mean. This may be due to the increased shear strength caused by stepping of slopes, okay, or additional loads. The reduction in the shear strength can occur due to the saturation, weathering, erosion, earthquake, rainfall, vibration, etc. Okay, the simple example is sudden slope failure during earthquake are caused by only rapid loss of shear strength only. Right. Here these are all the method of slope stability analysis. Three categories are there: frictional circular method, Bishop simplified method, Feedy's circle method. Okay, in the we discuss one by one. The first one is a friction circle method. Here friction circle method is a graphical method used mainly for a homogeneous cohesive soil. A circular slip surface is assumed and a friction circular is drawn with a radial equal to r sin pi. Okay, the method is based on the force equilibrium and help determine the factor of safety to slope. And also the main forces acting on the sliding masses are its self weight, cohesion, along with the slip surface and normal reaction. The resultant reaction is assumed to be a tangential to the frictional circle. Here the factor of safety is obtained by comparing the resisting and driving moment. The slope is considered stable when the factor of safety is greater than 1. Here the second method is Bishop simplified method. Here Bishop simplified method is a widely used and accurate method for slope stability analysis. The soil mass is divided into vertical slices and only vertical interslices forces are considered only. Okay, the method uses of more columns failure creation and allow inclusion of pore water pressure. But in here, the factor of safety is calculated by satisfying both the force equilibrium and the moment equilibrium. But in the sense, the factor of safety appears on both sides of the equation. An interactive solution is mainly required. This method is suitable for both cohesive and cohesionless soil. Last method is Swedish circular method. Here this method is also known as an ordinary method of slice. Assume a circular failure surfaces and neglect inter-slice forces. Okay, here the soil mass is divided into slices and stability is analyzed based on the movement equilibrium. But here in the factor of safety is obtained by comparing resisting the and driving movement only. Since interslide forces are neglected, the method is conservative and less accurate for the soil with significant frictional. Okay, here the column is represent the three analysis: friction circular, Swedish, Bishop. The accuracies for frictional circle is low moderate and Swedish circle is moderate and Bishop method is very accuracy is high, and it is suitable for all type of soil for Bishop simplified. But in the Swedish circle method, cohesive soil only involved, and also frictional circle method, homogeneous soil is used. Okay, the next one is improving stability of slopes. Here various methods to improving the stability of slopes are used in the recent decades. The slope stability can improve by flattering the slope, providing the beam or beam near toe, or improving drainage to reduce the pore water pressure, or densifying the soil, or installing sheet piles on retaining wall and stabilizing the soil, okay, using the chemical or mechanical methods. So various process involved to improving the stabilizing the process. Finally, to conclude, slope stability analysis is essential for safe and economical design of slope in civil engineering, and understanding the failure mechanism and analyzing methods help engineer prevent the disaster and ensure long-term stability of the structure. Okay, thank you for watching.